Hello everyone, this is Deepa Saxena Mehta. I'm a system hardware engineer at Facebook. Today my colleague Benway, who is a system software engineer at Facebook, and I will be going over the system manageability for a very modular design. So we'll be discussing two parts today. First, I'll go over the system management complexity for future modular platform using Yosemite v3 as a case study. Then Ben will go over the open source embedded Linux distribution for baseboard management controller using Yosemite v3 BMC as a case study as well. So let's get started. I'll start right now with to discuss system management complexity for future modular platform. Let's get started. So Yosemite Compute Design has a baseboard with shared NIC that manages server boards and its expansion cards. Each server board can have a bunch of flash attached to it. You can have up to 2 to 4 server boards with expansion card in a system. The expansion cards can be bunch of flash or bunch of accelerators. Let's discuss flexibility of design versus system manageability. So let's start with the system management. After 2 years of Yosemite design, we're always mindful of the system management complexity for this modular flexible design that we are creating. So when we say system management consideration, we consider design for the following: firmware upgrade, telemetry, failure detection. You have to keep in mind that ease of management is important in data centers, and that's the focus of our discussion today. So let's move forward. Let's talk about firmware management. In Yosemite modular solution, we can have minimum of 2 to 20 firmware that would need update in a data center. When I say that, what are we talking about? Each components like the BMC has its firmware, NIC has its firmware, the server board comprises of either BIOS or the bridge IC. And that firmware has to be upgraded, followed by any of the endpoint devices or the accelerator devices that needs firmware upgrade during the life of the product in the data center. So what do we consider? Speed of upgrade. How long does it take to upgrade any given firmware? Is it in seconds, minutes, or hours? Update method and failover. Can we do in-band upgrade or only out-of-band is feasible? If you're using out-of-band as a failover method, how long does it take to do the update in this failure mode? Version control. Can the firmware be rolled back? Can I update 2 firmware versions up or 2 firmware versions down to recover to a known good firmware? Secure update. Is the update provided in a secure manner? Can the update tool manage secure update? How the key and the hash management works? Next is sequence of update. In Yosemite design, we need to ensure that the BMC firmware is up to date and can then update the components downstream to it, like the BIOS and the BIC, before any of the devices that come as on the expansion card can be updated. Next, we need to consider telemetry as piece of system management capability. When we say telemetry, we are looking at what kind of readings and information that can we get from the system that we can monitor. So some of the things that we are considering is sensor reading, the rate of polling for different sensors. Each of these components, the CPU, memory, VR, BMC, NIC, PCIe endpoint devices, accelerator would have some kind of sensors. So how do we get that sensor reading out of it? The thresholds, upper and lower threshold level based on the environment that the system is deployed. The third one is the vendor sensors. When we design, we need to look at the design not only from the speed and bus capability and the functionality, but also the sensor readings and monitoring and failure capability that these vendors have. So we need to review it and ensure that we have a clear understanding on how that can be utilized for telemetry purposes. System and rack level. Why we are bringing this up? Because it's not only system level or server level information that we collect, but we need to think about it in terms of overall rack management. And these racks sit, and several of these sit in data center. So we need to collect a lot of these information and ensure they're robust, the thresholds are set correctly, and each of the components that we have in the system has telemetry information that we can utilize and monitor. The third aspect of system manageability that we would like to discuss is the failure detection. Any seasoned system designer appreciates failure would occur in a system. It can be at a software level, a firmware level, or a hardware level. What is important is when these failures occur, can we detect those failures? Are they correctable or uncorrectable? Can we identify components, the bus, cable that failures occurred with? The second aspect that is very critical in the data center environment is remediation. Can the errors be fixed through reboot resets or fixed through some software and firmware upgrades? Repair is a part of failure detection that we get to in the flow, that we get to when the failure is unrecoverable. We know that the component is damaged now and has to be replaced. But when you consider repair, you have to consider this last aspect, which is very important and critical in the data center environment: downtime. Repair impacts system downtime. We need to ensure that we can collect enough hardware information to make the determination which component failed in this complex system and provide that information to the technician to make that repair in a short amount of time. Downtime always leads to loss of production services, which means loss of business. And hence we have to be very mindful of the downtime, and the flow of detection, remediation, repair, and downtime is an important aspect of system manageability for any data centers. So let's wrap this up. What we want to take away from this section is, when designing for system management, design for system management at scale. Thank you so much for your time, and we look forward to your feedback and responses. Have a great day. Bye.
Thanks, Deepa. I'm Ben Wei, System Software Engineer at Facebook. As Deepa mentioned, Yosemite V3 runs OpenBMC as its management software. OpenBMC is an open-sourced embedded Linux distribution whose main job is to enable monitoring machine health, log system events, and provide remote management capabilities such as sensor reading and firmware update. It uses Yato project as its build tool, and all source code are available on GitHub in the link we shared in the slide. OpenBMC supports traditional IPMI interface as well as REST API, but its main management functions are invoked through SSH to BMC and through command line interface. And here I'll give an overview of the OpenBMC stack. On the hardware side, we have the BMC SoC, which is the HP2500, with various buses and GPIOs connected to the rest of the system. It runs U-boot and Linux kernel to provide a familiar look and feel of any Linux system. All management functions are implemented as a user space applications. So there are various monitoring daemons for sensors, for fan speed, for incoming IPMI messages, for example, and a separate command line utilities for each management functions, such as flow read, sensor and log reading, and firmware update. To show this, I've provided an example of what OpenBMC looks like from user point of view. So it shares the familiar look and feel of a Linux system, such as having bash script, having bash and shell scripts. And user in other program can invoke management functionalities through command interface. So in the screen capture, I have two examples. So first is the power util, which provides remote power management capabilities to each server within the Yosemite V3 platform. Second example here is the sensor util. So user can run the command, get a help message, and read each individual sensors, or try to read all sensors in the system. Also, it provides us other information such as sensor history and threshold information. So these are just two examples, but on the OpenBMC GitHub site, we have much more information for each command line and their functionalities. Great, I'll hand this back to my colleague Deepa. We will publish any additional system management updates for Yosemite V3 through the white paper in OCP. Also, there are other presentations in the server track on YV3 Yosemite V3 systems. So if you need any more information, please attend those sessions. And as always, any comments and feedback, please reach out to us, Deepa and myself. Our emails are in the slide. I'd love to hear feedback from you. Okay, so this is the end of our presentation. Thank you very much, and we'll be here for any questions. Thank you.
Thank you, Ben. So you can see we have, let's take 5 minutes for Q&A. I see one question raised on the chat. Is how do you address, I see the problems raised, how do you address them in Yosemite? So some of the effort that Ben also walked through that we have worked through is created cell detail, which is more unified and human readable format that we are working through so that we can quickly identify where the error came from and report it in a cell log that is then can be utilized by the techs in the DC, and then they can utilize that information and determine where in that complex modular system that the error occurred, whether it was the BMC on slot 1, slot 2, slot 3, slot 4, where did that come from? Was it a device on a slot 1 versus a device on a slot 4? So to remediate that, that's how we are handling the modularity issue, and a lot of that is to do with the interaction with BMC and cell log capture. Thank you for that question.
Yeah, just add quickly to what Deepa just mentioned. It's actually exactly like what Deepa said in BMC provide utility to both polling, so which user can actively poll the status of each component, or the cell log, which user can then query to see the component failure and such. Okay. I see there's a...
Go ahead. There's another question.
Yeah, I can take this one, the PODM protocol. So OpenBMC today OpenBMC in Yosemite v3, we support PODM over NCSI. So primarily, this is for niche. So we support PODM sensor discovery. So this is for niche monitoring. And also we use PODM for niche firmware update. So for other devices in a system, we are still working on this, but it depends on device support as well. So today on the YV3 system, the only device capable of PODM is the network controller. So if there are other devices, we love to support them via PODM over MCTP. Redfish device enablement is not in OpenBMC yet. It's currently ongoing, but we don't have support for this yet in the YV3 OpenBMC. But this is still work in progress. Feel free to reach out to me and Deepa afterwards. We can discuss more if you have a specific use case for Redfish.
Your time, and do send us an email if you have follow-up questions. That will end the session. Thank you.
Thanks very much.